Okay, let's talk about this problem and how we divide the areas up. And so an electrical cable runs across a block of land, and then Doc decides that the land must be divided into 4 pieces of land, each of at least 500 square meters. So that gives us a lot of leeway. It has to be above 500 square meters. So the thing is that this can be done in multiple ways. And so I just want to show you one of the ways that we can do this. We can consistently do this and make sure that we've covered the internal. So the cable, first of all, you want to find FH, because we need to find the area of basically FEH and then of FGH. And once we know those areas, then we can figure out how we're going to divide them up into various shapes. And so we'll work through this. And the thing is that the first part of the solutions is fairly straightforward. You're going to find the area of FHG, which you can do because you've got the angle and you've got all the information that you need, and you end up getting 1453.4. And then you find the length of FH by using the cosine rule, and you get 62.7. Now, once we get 62.7, then we can use the cosine rule to find an angle. Remember, we use the inverse in the calculator, and so that we can find FEA. And then by doing that, we can find the area of the other triangle, FEA, or FEH, sorry, and that's 1060. Now, at that point, we stop, because that's what everybody should be doing, right? That's the consistent thing. Find the missing side that goes across, find the 2 areas, and work from there. So you know the area of the big triangle, the big triangles. We know this area here. And we want to figure out how we can break this whole paddock up into 4 bits. Well, we can draw a line across and do it like this. This is going to break it up into 4 bits. And then we have to decide, well, these 2 bits here have to be greater than 500, and these 2 bits here have to be greater than 500 square meters. Now, there's a lot of ways that you can do this, but a very consistent way is to say, well, what if we divide the shapes in half? Like, what if we do so that the areas are half of the big triangle? And we know that the relationship between the areas so we know that relationship, and we can deal with that. We also know that we could assume isosceles triangles. We've got a couple of methods that we can use if we're going to assume that the areas that we're going to break the shapes up into half. So first of all, if we break the shapes up into half, let's see what happens around the fact that what does taking half the area give me? Well, the half of the area of FHG is 726.7. So that's more than 500 square meters. So that meets the criteria. And if we take half of 1060, half of that is more than 500. So we would then theoretically get 2 areas that were bigger than 500 square meters if we divide both those sections in half. So we've done that. We've talked about how that can happen. We can divide it into half. But now we've got to get into the how can this be done, and what strategies would we use for how this can be done. So this is where the next phase of things comes in. Well, how can this be done means that you can assume isosceles triangles. So that you give those 2 sides, and if we use FEH, and this is A and B, then basically AE and EB are equal, and they are X. Now you could give them a measure, but I think it would be easier and more to the point if we said, okay, well, let's just take the area of AEB, and it's going to be equal to 1/2 times the 2 sides, which is in this case x squared, times the sine of 83.9, because that's what we found that to be, and that area is going to be in fact equal to 7. What was half of it? 70. We're doing we're doing FEH, FEH, FEH. FEH was 1060, so we're taking half of that, which is 530, right? 530. 530. And then we go about solving for, so we times by 2, and we times by 2, and we get x squared times the sine of 83.9 is equal to times 2, 5, which is 0, 6. You know that. And then we divide by the sine of 83.9, and we square root that. So square root of 1060 divided by the sine of 83.9 is 32.65 to 2 dB. Okay? So we've now got these be 32.65 and 32.65. Now we need to test that, right? We can't just assume that that's going to work. Let's just test it. 1/2 times 32.65 squared times the sine of 83.9. What does that give me? That should give me something close. 2.65 squared times 0.5 times sine of 83.9. 529. Point close to my, it's obviously, you know, 0.99. So it gives me my 530. That works. And then what I do is I take the 1060 and I minus the 530 from it, because that's going to give me the other shape. 1060 minus 530 is also 530. Imagine that. Did I have to do that? No. So I've got two areas, this area and this area, that are both 530. Taking half. That works. It works perfectly fine, and I've proven that it works. Now, could I have done the other option, which is to use the 530 over 1060, those are the areas of A1 over A2, is equal to the square of, doesn't matter which side I use, 52, right? And so then I do that relationship, and then I can do the square root of that, which is 530 over 1060, but we've already talked about this. The square root of 530 divided by 1060 is 0.71 is equal to x over 52. So basically you're taking 0.71 of the long side to find the short side. So why don't I just take 0.71? I don't have to do that every single time. So why not take 0.71 of 52? And that's 36.92. So now I'm saying that this smaller triangle here, this side is 39.92. Is that what my calculator said? 36.92. And then I have to find this side. So I can use my formula in various ways. I know what this is. I know what this is. I can, I can basically find this side by sticking it into the formula, and I decide what formula you want to use to find that side. You can use the area formula, because we know the area of this triangle here is 530. So it's going to be half A times B times the sine of C, but it's going to be equal to 530, yeah? So if I put 1/2 times 36.92 times B times the sine of 83.9, I'm going to get, it equals 530. I'm going to be able to find what B is. So you can do this in various ways. I wouldn't just randomly pick a side like what they've done in the solution. I would do this, and then you're going to have to do exactly the same thing. Once you've done the top triangle, whatever triangle you do first, then you're going to have to do exactly the same thing for the bottom triangle. And once you've got your dimensions and you've shown that it works, you have to take away from the big to get the, the other area and so on.